So when you set up number 10, what's the gravitational force between a spatula and a wrench that are separated by a distance of 0.35 meters? So the things that we know are the mass, which is 0.3. So we'll call that mass 1. And the mass of the other object, we'll call that mass 2, which is 2.4. And the distance between them to be 0.35. So I look at my equations for this unit, and I say, okay, I'm trying to find an equation that has to do with gravitational force, and that talks about the masses and the distance between them. So no, that's period. No, that's tangential velocity. No, that's tangential and rotational velocity. No, that's rotational velocity. No, that's centripetal force. We're getting closer, but centripetal force is for moving in a circle, and the wrench and the spatula aren't moving in a circle. So it's got to be this one. Force of gravity is big G m1 m2 over d squared. So that's the equation I'm going to write down. There we go. All right. So now that I've got that written down, now I'm ready to plug my numbers in. So Fg is what I'm solving for. What's the force of gravity? I'm going to come back to big G. M1 is 0.3. M2 is 2.4. And then the distance between them squared. So the distance is 0.35 squared. So a lot of people plugged in 9.8 for big G. And I want to make sure to point out to you that there's a difference between big G and little g. So little g is 9.8. Big G is this big nasty guy. Now, this is the actual number. This is just a unit. So don't freak out about this stuff. That's just the unit for G. This is the actual number. So I'm going to plug that number in. 6.67 times 10 to the negative 11th. So let me show you how to plug it in your calculator, because some of you may have had trouble with that. So to plug it in your calculator, you're going to do the following. I like to put in the power first. So that number is going to be like this, 6.67. If you have a TI calculator like mine, you're going to hit this number here, this button, EE. That does times 10 for you. You do not need to hit times. You don't have to hit 10. You don't have to do a power. You just hit that button. Now I put the power in. The power is negative. Don't use minus, use the negative sign, negative 11. Okay, I don't have to hit equals because this isn't a math problem. This is just a number. So it's like 3. It's just a number. So now I'm going to multiply that by 0.3. Okay, I'm going to multiply that number by 2.4. And I'm going to divide that number by 0.35 squared. Now I hit equals. And there's my answer. So 3.9 times 10 to the negative 10th, that is my answer. And this is newtons for the unit. And if you're saying to yourself, well, that seems like a really small number, the answer is yes, it is really small, because gravity is not very large between objects that are not super heavy. So it makes sense that the number is very small here. All right, excellent. All right, 21. So a 50 kilogram car is moving south at 10, collides with a 50 kilogram car going north. The cars stick together and move as a unit after the collision with a velocity of 5.22 meters per second to the north. Find the velocity of the 50 kilogram car before the collision. So a couple of things here. The first thing you should do is you should do your knowns and unknowns. So the mass of object 1, so we'll call the first car 1550. The mass of the second car is 2550. Okay, then we start getting into velocities, and there's two different velocities. There's a velocity before they hit, and then there's a velocity after they hit. Okay, so it says that the first car is moving south at 10. It does not say how fast the other one is going. In fact, it says find the velocity before the collision of the other. So I'm going to put a question mark for that one. And then it says they stick together and move with a velocity of 5.22 to the north. So both of them have the same final velocity. Okay, I would encourage you to draw a diagram for this. A lot of you got close to the right answer, but not the right answer. And if you drew a diagram, I think it would help you see that. So here we're going to do a before and after. So the before is car 1 is moving south, and car 2 is moving north. It's going south at 10. The other one's going north at something. I don't know how fast it's going north. After the collision, they stick together and they both go north. At 5.22. Here's why drawing the diagram helps. Once I look at this, I say to myself, oh, self, they're not in the same direction. Something's got to be negative. Now, it doesn't matter if north or south is negative, but you're probably more used to making south negative, so I'm going to make the 10 negative. Now, if you didn't make the 10 negative, then you would need to make the question mark negative, which is kind of weird, or you could leave that blank, but you would need to make the Norse negative then. So that's probably less familiar with you. So I would make the south negative. All right, now that I've got my knowns and unknowns, now that I drew my diagram, now I'm ready to figure out the equation to use. There are two equations in momentum that you use the most often, and that is this one and this one. So this first equation, this is what you use when you're talking about one object and what happens to it because of being hit by something else. This equation is what you talk about when you talk about two objects and what happens to both of them. So this is a problem of two objects, a car north and a car south, and what happens to both of them. After the collision, they both stick together, they both have that speed. So this is a before and after, which tells me that's this equation here. What happens to both objects? So I need to find the initial momentum of 1, the initial momentum of 2, the final momentum of 1, the final momentum of 2. And the way you find momentum is this guy, P equals mv. So I'm going to do that for all of those. So momentum initial for 1 equals momentum final for 1 equals momentum initial for 2 equals momentum final for 2 equals. And I'm just going to do P equals mv for all of those. Okay? So P equals mass times velocity. So you might be saying to yourself, well, Mr. B, we got a lot of masses and a lot of velocities. Which ones do I use? So if I'm doing one initial, I use all of the ones, so these three, and I only use the initial values. Well, mass never changes, so it's 1550. And the initial of 1 is negative 10. So this would have a momentum of negative 15,500. Okay, final of 1. So the final of 1 is its mass times its velocity. So 1550 times the velocity at the end, which is 5.2. And when I multiply those together, give me 8,060. Now I do the initial of 2. So the initial 2 is mass times its initial velocity. So I don't know what that number is. Okay, I don't know what that number is. So there's 2 ways you could do this. You can either just say initial of 2 is question mark, or you could say the initial of 2 is 2550 times V2I. It doesn't matter which way you do it. I'll show you both ways kind of here briefly. The final of 2, though, 2550 times its final velocity of 5.2. So that one, $13,311. So now I'm going to add up together my equation. Initial of 1 plus initial of 2 equals final of 1 plus final of 2. So initial of 1 is here, and I'm going to break this up a little bit. So the initial of 1 is negative 15,500 plus the initial of 2. I don't know what the initial of 2 is, so I'm just going to write P initial 2. Or I could just plug this in, 2550V. That's going to equal the final of 1, 8,060, plus the final of 2, 13,311. So now I'm ready to solve. I'm going to get P12 by itself, or P initial 2 by itself, and then once I get that number, I'll use this, P equals mv, to find the velocity. The mass will be the mass of object 2, and the momentum will be the answer I find here. Okay? So try that to finish it up. If you want to mark down the other questions we were